This week, we continued to collect data at different locations and compression rates. Data was collected using the CPR device, as well as at a variable depth without the device using a mattress, cushion, and couch. We faced some challenges with our segmentation processes, and we were required to make some adjustments which produced promising results.
The following video will explain the proof of concept CPR device to show it in action and provide a demonstration of how it works. The device consists of a simple compression spring mechanism that allows the user to press down and offer resistance. The spring then returns the device back to its original position once pressure is no longer applied. Measurements are gathered at specific compressions per minute by syncing compressions to a metronome that is set to the target beats per minute. We can also vary the depth with the placement of spacers of different sizes to prevent the spring from compressing past a target distance. As can be seen here, the standard compression depth is approximately 2.15 inches in length.
We have organized locations that we have started to and will continue to perform compressions at for collecting varied data. The mattress, couch, and seat cushions such as a dining chair will be measured at variable depths since it will be difficult to track consistent depths while performing compressions. The CPR device will be the main method to measure at the specified depths of approximately 1, 1.5, 2, and 2.5 inches. All of these measurements will occur at the specified rates from 80 to 140 compressions per minute. Thus far, we have collected 409 individual compressions, with each set of data being approximately 50 compressions. The plan is to add on any necessary measurement targets as we move forward with analyzing the data.
After plotting the data gathered, we have made some interesting observations. Both the mattress data and CPR device exhibit similar wave patterns when magnitude is plotted over time. However, the mattress data seems to be smoother than the data provided by the CPR device. The jagged areas in the CPR compression device are circled red, which are not observed in the mattress data. This has led to some small inconsistencies in accurately measuring the compression count and rate for the different target rates of compression.
An example of this was in the dataset for 140 compressions per minute and a 2-inch depth on the CPR device. We noticed that the compression count and BPM calculations were off by a count of 1 even after fine-tuning the threshold and filtering window parameters. An additional peak magnitude circled in red on the graph was counted that was not a peak magnitude. The actual compression count was 49, but the calculated count was 50. This skewed our rate measurement to being 143.88 compressions per minute instead of the expected 140 compressions per minute. While raising the threshold could theoretically solve this issue for the data, it would ultimately skew the compression count calculated for other data sets at other compression rates and is not a robust solution.
In order to increase the accuracy of counting compressions, and therefore increase the accuracy of measuring the rate of compressions, modifications to the compression count method were performed. Previously, the method measured the max magnitude above a designated threshold. Now the method also segments the data at times where the magnitude went below 10. This way, the method could keep track if two magnitude peaks are on the same compression, and if so, only tracked a greater magnitude. A magnitude of 10 was selected because it was close enough to the gravity of Earth, and therefore provided a good reference point for when there would be no additional exerted acceleration during the movement of the compression.
As can be seen here, this has worked well so far for accurately tracking compression count and average compression rates across the data that has been gathered. We will continue to gather data and test our compression count and rate calculating methods for accuracy.
Our work next week will consist of collecting additional data as well as entering part 3 of our project, the app creation phase. In Check-in 4, we will begin focusing on UI components and create low fidelity and explore rapid prototyping methods to lay the groundwork of what the look and feel of our future app will be.